Alright, so y'all go ahead and do the factoring and the math knowledge question for today. Pause the video, and then once everyone is finished, you can unpause the video and I'll go over the correct answers. So for the factoring, you should have x plus 13 times x plus 4. For the math knowledge question, it wants us to find the length of CD. And they tell us we have A, B, C, D is a square. So if we find the length of one side, that'll give us the side length for CD. And it tells us that A is -3, 0, and B is 0, 3. So if we find the distance between those two, that'll be the same as the distance between CD. So if we use our distance formula, you'll have -3 minus 0 squared plus 0 minus 3 squared. So that'll be -3 squared, which would be 9, -3 squared, which is 9 again. So the square root of 18, which if you simplify, would be 3 square roots of 2. So D would be your answer. Okay, so we are looking at lesson 38 today, perpendicular and angle bisectors of a triangle. So a few lessons ago, we looked at the point of concurrency of the medians and the altitudes. And today we're going to look at the other two points of concurrency, the perpendicular bisectors and the angle bisectors. So again, one of your projects this year will be on these 4. So this is going to be a lesson that you want to focus on when you go to do that project. So hopefully you'll understand perpendicular and angle bisectors today. So an angle bisector is going to divide an angle into 2 congruent angles. We've dealt with angle bisectors before. It just cuts your angle into 2 congruent pieces. When all 3 of your angles of your triangle are bisected, the point of concurrency is called the incenter of the triangle. So angle bisectors are your incenter. The incenter is always equidistant from all of the sides of the triangle. So let's look here. Theorem 38.1, the triangle angle bisector theorem. If you have a line that bisects an angle of a triangle, then it divides the opposite side here proportionally to the other side of the triangle. So here's what you get basically. PM over PO equals NM over NO. So this over that equals this one over that one. That's how you can set up your ratios. So if we have this triangle here and we want to find SP, that's the length of X, we can say this side 35 over X is going to equal 50 over 44. That's how you're going to set up your ratios every time. Side over this side, and then this side over that side. And then you're going to cross multiply and divide. To get 50x equals 1540. And then x would be 30.8. So that's the length of SP. So that's how that one would work. Now looking at the circumcenter. The perpendicular bisector is when you have a line that is cut in half by a perpendicular line. So this is the perpendicular bisector. It's perpendicular and it bisects. When you draw your 3 perpendicular bisectors, the point of concurrency is called the circumcenter. And the circumcenter is always equidistant from every vertex in your triangle. So the incenter was equidistant from the side. The circumcenter is always equidistant from the vertex. So that would be your circumcenter. This distance here, and this distance here, and this distance here are all three the same. Your circumcenter doesn't have to be inside of a triangle. A right triangle circumcenter is going to be somewhere on the hypotenuse, and an obtuse triangle circumcenter is going to be on the outside of the circle. For an acute triangle, it is on the inside, but not for a right or an obtuse triangle. The circumcenter is going to lie at the center of the circle that contains the three vertices of the triangle. So if we draw a triangle, and we draw a circle that contains those three, wherever the circumcenter is going to be the center of this circle. So any circle that contains all the vertices of a polygon is called a circumscribed circle. And that's because it is going around the polygon. It's going about it. And then any polygon where you have your circle and then the vertex is on the inside. Y'all see how the triangle's on the inside? That triangle is an inscribed triangle, or just an inscribed polygon, because it's on the inside of your circle. So we'll deal with circumscribed and inscribed more later in the year, but the book does introduce them in this lesson. So let's look at this little picture. This triangle here, the circumcenter, is O, because that's the center of the circle that has all three vertices on the circle. And if you notice, TO, RO, and SO are all three radii of that circle, and that's why they all three are the same distance. So let's look here. We want to find the circumcenter of the triangle with the vertices at 1, 7, 3, 1, and -3, -5. So the first thing we need to do is graph it. So there's D, there's E, and there's F. Okay, so that's my triangle, and the circumcenter is where the perpendicular bisectors meet. So we need to find the midpoint of each side. So the midpoint of DE, add your x's and divide by 2, add your y's and divide by 2, would be 2, 4. So that would be your midpoint. The slope of DE would be 7 minus 1 over 1 minus 3, which is 6 over -2, which is -3. So the perpendicular slope would be positive 1/3. So you're going to make a line that has a slope of positive 1/3. Okay, so that's the first one. Now let's try another one. The midpoint of, we'll do EF. If you add those and divide by 2, you get 0 and -2. And then the slope of EF would be y minus -5, and then 3 minus -3. So that'd be 6 over 6, which is 1. So the perpendicular slope would be -1. And if you look, they intersect at that point right there. So you don't actually have to find the third one, because if 2 of them intersect, then the third one is going to intersect at that same spot. But if you're not sure if you did one of them correctly, then go ahead and do the third one, and it should intersect in the same spot. But the circumcenter is going to be -4, 2. So that's how you find your circumcenter. If they hadn't intersected at an exact point, you would need to find the equation of this red line, and the equation of the green line, and then set them equal to each other and figure out where they intersected. So hopefully that doesn't happen terribly often because that just requires a little bit more work. But if so, that's all you have to do. Okay, so looking at another example, we have 3 schools that are located at 1632 and 92, and the city wants to build a playground equally distant from each school. Where should it be located? So the first thing we need to do is to draw our triangle. Okay, and if it's asking about equally distant from each school, each vertex, that's going to be your circumcenter. It doesn't ask for the circumcenter, it just says the one that's equal distance from each school. So you have to know that that means the circumcenter. So the first one that's going to be the easiest to do is going to be K to L. So halfway between the midpoint between K and L would be 6, 2. And it's a horizontal line, so the perpendicular one is going to be vertical. And then we can do JK. And the midpoint would be 2, 4. And then the slope of JK, 6 minus 2 over 1 minus 3, 4 over negative 2, which is negative 2. So your perpendicular slope would be positive 1/2. And that's where they intersect right there. So 6, 6 would be where we would want to locate the playground. So that's how those work. Okay, so now let's look at some practice problems. The first one asks to use a compass and a straight edge to find the in-center. Typically, we're not going to find the in-center, so we're skipping part A. But y'all see if y'all can do B by yourself, and then we'll go over it. So we're looking for the length of TU here. We don't know what that is. So we're going to say 10 over 6 equals x over 4. So 6x equals 40. So x would equal 20 over 3, because that's what 40 over 6 reduces to be. Or you can make it a decimal if you would rather. Okay, so let's see if y'all can do this one by yourself, and then I'll go over it after y'all have attempted it. So we're going to have our points 3, negative 1, negative 1, negative 4, and negative 3, negative 1. And then I'm going to start with this horizontal one, and the midpoint between 3, negative 1 and negative 3, negative 1 is 0, negative 1, and it's going to be a vertical line. And then I'll do the one on the left here. You could do the one on the right, either one is fine. But that would be between these two. So the midpoint would be negative 2 and negative 2.5. So negative 2, negative 2.5. And then the slope between those, negative 4 minus a negative 1, and negative 1 minus a negative 3, is negative 3 over 2. So the perpendicular slope would be positive 2 over 3. So if we go up 2 and then over 3, we get that one right there, which doesn't go through this point exactly. So we actually end up having to figure out the equations of the lines. So the green line equation is a vertical line, so that's going to be x equals 0. Now for the red line, we know that its slope is 2/3, and then it goes through the point -2, -2.5. So if we use y equals mx plus b, that'll give us the equation of that red line. So -2.5, 2/3, -2 plus b. So I'm going to change this into a fraction. -5/2, -4/3 plus b. So when I add the 4/3 to the other side, I can make a common denominator of a 6. So that would be -15 plus 8. And so your b value would be -7/6. So your equation for the y equals 2/3 x minus 7/6. That would be your equation for the red line. So then whenever you plug in x equals 0 here, this whole term would be 0. And so your y value would be -7/6. So your circumcenter occurs at 0, -7/6. So you got to be really careful that if it doesn't cross exactly through it, don't just go, oh, that looks like it's -1. -7/6 is close to -1, but it's not exactly -1. So you got to be really careful when you're doing these, that you don't assume that it crosses through a point if it doesn't. Okay, let's look at one more. We have a restaurant owner that wants to place his new restaurant equidistant from 3 grocery stores, and they're located at 00, 40, and 06. Where should he put the restaurant? So the first thing you want to do is to graph it. So we have A, B, and C. And then we've got two sides that are going to be super easy to find because they're horizontal and vertical. So the midpoint of this one is at 20, and it goes vertically. And then for this one, the midpoint is going to be at 0, 3, and it's going to be a horizontal line. And so these intersect at this point right here, which is 2, 3. So hopefully y'all are able to get most of those correct. You do have to practice them, but hopefully as you practice them, you'll get a little bit better at working through them. So now we're going to look at the review of the points of concurrency. I want y'all to put these down so that you can refer back to them. You need to learn that the medians all intersect to form the centroid. Your altitudes form your orthocenter. Your angle bisectors form your incenter. Your perpendicular bisectors form your circumcenter. You have to know those. One pattern that I've noticed, these are your vowels, and these are also your vowels. This is a consonant, and these are also your consonants. So vowels go together, consonants go together. So that'll at least give you down to a 50-50 shot there. So now we're going to look at your challenge question. We want you to construct the incenter, the circumcenter, and the centroid of an acute triangle, the incenter, circumcenter, and centroid of an obtuse triangle, and then what is the relationship about the incenter, circumcenter, and centroid for any triangle. So your incenter is going to be where all of your angle bisectors intersect. And so let's say that's an angle bisector, and that's an angle bisector, and that's an angle bisector, and you'd have to show that these angles are congruent. The circumcenter is where you have your perpendicular bisectors, and so these are your midpoints, we'll say. And if you draw it perpendicularly, well, that didn't go so well. Your circumcenter is the only one that does not have to go through the vertex. So that could be your circumcenter. And then the centroid is where your medians intersect. So you always start at a vertex for those. And then you would just show that these are congruent, and these are congruent. That would be for your acute triangle. The obtuse triangles are a little bit harder to do. So bear with me as I try to draw them. So your in-center, those angles are congruent. These angles are congruent. And then those angles are congruent. So there's your in-center, as best I can draw it. Your circumcenter is going to be on the outside of your triangle for an obtuse figure. So we'll say that's your midpoint for each side, and then they're going to be perpendicular. And so it should intersect about right there. And then your centroid is, we'll say, about right there. So that's a rough sketch of those. It's hard to draw them without a ruler because they don't look so great. The in-center, circumcenter, and centroid relationship on a coordinate plane is that they are all collinear. So if you draw in-center, circumcenter, and centroid for any triangle, they're actually all going to be, all three of them are going to end up being collinear, which is pretty interesting because they're 3 points, so you can actually connect all three of them in a straight line. Okay, so your homework is 1 through 30, so y'all make sure to do those tonight so we can go over any questions you have.